Hi everyone, my name is Mubashir Shamim from the CS department of Shri Venkateshwara College of Engineering. Today we're gonna discuss about corrosion. The topics in corrosion, the topics we're gonna discuss today are definition of corrosion, electrochemical theory of corrosion, types of corrosion, causes of corrosion, corrosion control, corrosion penetration rate. The first topic is definition of corrosion. Corrosion is defined as the destruction or deterioration of metal or its alloys and consequent loss of metals caused due to the direct chemical action or electrochemical reactions with its environment. Several metals undergo corrosion when exposed to air, water, or other substances. The primary factors which initiate corrosion of metals are atmospheric air and water. Corrosion of metals can be regarded as the reversal of its extraction. So the next topic is about dry corrosion and wet corrosion. What is dry corrosion and what is wet corrosion? Dry corrosion, sometimes also called chemical corrosion, is a type of corrosion that occurs without moisture or water, which are the main drivers of the conventional type of corrosion. In dry corrosion, metal oxides with only the atmosphere in a process sensitive to temperature. Dry corrosion therefore refers to an oxidation process sustained by oxygen in the air without a liquid solution. On the other hand, what is wet corrosion? Wet corrosion of metals occurs through electron transfer involving two processes, oxidation and reduction. In oxidation, the metal atoms lose electrons. The surrounding environment then gains the electrons in reduction. The metal where the electrons are lost is called the anode. The other metal is liquid or gas which gains the electrons is called cathode. So the next topic is electrochemical theory of corrosion. According to the electrochemical theory of corrosion, corrosion of metal occurs due to the following changes when they are exposed to the environment. A large number of minute galvanic cells are formed which act as anode and cathode areas. At anode, the metal undergoes oxidation and electrons are liberated which migrates towards cathode region. Most of the corrosion takes place on the basis of electrochemical reaction on the surface of metals. Such type of corrosion is known as wet corrosion. Types of corrosion: galvanic corrosion, uniform corrosion, stress corrosion, cracking, crevice corrosion, pitting corrosion, hydrogen growing, high temperature corrosion, graphite corrosion, microbial corrosion, metal dusting. Causes of corrosion: the first cause is moisture. Metals tend to corrode at a much faster rate in the moist or wet environment. Second cause is temperature. An increase in temperature increases the rate of corrosion. Third cause is exposure of metals to air conditioning gases such as CO2, SO2, SO3, CO2, SO2, SO3, etc. increases the rate of corrosion. Fourth cause is presence of impurity such as salt, NaCl. NaCl increases the rate of corrosion. Fifth cause is nature of the first layer of oxide formed. Aluminium, being a reactive metal, does not corrode like other metals. It forms a protective layer of aluminum oxide on corrosion which prevents the metal from further reacting with the environment. Sixth cause is types of metal. All metals do not corrode. The metals that are placed higher in the reactivity series such as iron, zinc, etc. corrode very easily, whereas metals placed lower in the reactivity series such as gold, platinum and silver do not corrode. Corrosion control. Corrosion is an undesirable phenomenon that we need to prevent because it causes much damage to metallic structures like bridges, statues, monuments, metal utensils, and many more. All corrosion prevention methods are based on a fundamental concept that is to cut off the water and air supply to the metal. Some of the preventive measures of corrosion are discussed below. Painting. Painting iron articles such as iron gates, tracks, etc. stop metal exposure to air and water. Thus, corrosion is prevented by painting metallic objects. Oiling and greasing. Like painting, oiling and greasing also form a protective layer on the metal surface and protects it from corrosion. Galvanization. Galvanization is a process by which a thin protective layer of zinc is made on iron and steel objects. Even after this zinc layer is broken, the galvanized articles are protected from corrosion or rusting. Alloying. Alloys are the homogeneous mixture of one or more metals and non-metals. Through alloying, we can get the desired property of the metals. For example, iron is a very useful metal, but rusting occurs easily. Thus, when this iron is mixed with nickel and chromium, we get a stainless steel that does not rust. Nowadays, the stainless steel is very commonly used to make corrosion penetration rate. The corrosion penetration rate CPR is defined in three ways: the speed at which Any metal in a specific environment deteriorates due to the chemical reaction in the metal when it is exposed to a corrosive environment. The amount of corrosion loss per year in thickness, the speed at which corrosion spreads to the inner portion of material. The speed or rate of deterioration depends on the environmental conditions and the type of conditions of the metal under study. Corrosion penetration rate may also be known as corrosion rate. Several pieces of data must be collected to calculate the corrosion penetration rate for a given material. The weight loss, the decrease in weight of the metal during the period of reference. The density of the metal, the total surface area initially present, the time taken for the metal to corrode. The CPR is calculated as follows. CPR is equal to K into W divided by D into A into T, where K is equal to constant, W is weight loss, T is time taken for the loss of metal, A the surface area of the exposed metal, D is the metal density in gram per centimeter cube. The corrosion penetration rate is best expressed in terms of thickness or weight loss where the surface of the metal corrode. Thank you. Have a nice day.